The CCQ Fine-Tuning Work Group from Vale presents Automated Diagnosis of Mechanical Vibration for Conveyors. Vale's CCQ Work Group is the author of this project. To start the discussion, some important issues of the job site were raised. A prioritization matrix known as GUT, or Gravity, Urgency, and Tendency matrix, highlighted the occurrence of failures in components in the crushing conveyor circuit between inspection routes. The objective of the project was to reduce the occurrences of failure not identified during the inspection routes for collecting vibration and temperature in the conveyor circuit of the primary crushing. Currently, the route is performed manually every 15 days, but ideally the data would be collected continuously. Ultimately, the CCQ work group hopes to make advances in production, operational safety, and cost reduction. History. In 2020, a total of 188 failures were recorded between the mine's biweekly routes. The most significant problems were lubrication failure, contamination, looseness in the bearings and bushings, and misalignment. One problem was found to have occurred in the belt circuit of the crushing area, where the belt circuit is responsible for the logistics of crushed ore to the plant's buffer pile. In this circuit, we have a total of 264 vibration and temperature monitoring points. How the problem occurs. Belt circuits are dynamic assets that operate on a constant basis. Problems such as lubrication failure, water, and ore contamination can generate temperature rises in vibration, even if momentarily. But they can eventually evolve into a mechanical failure and even a corrective shutdown event. This is a problem when it comes to periodic offline routing. These major events go unnoticed at the time they occur and are not immediately addressed. However, the failure can be identified when collecting vibration data as part of predictive maintenance. The problem was identified. Occurrences of failure not identified during the inspection routes in the conveyor circuit of the primary crushing. The goal was established. Automate the vibration diagnosis of the primary crushing belts circuit until December 2021. For an effective treatment of the cause of the problem, an action plan was prepared and executed after aligning across different teams and the installation of wireless sensors along the conveyors. The action plan was successful and resulted in the creation of an automated detection dashboard, which can be used to assess the health status and view a diagnosis for each monitored asset. Verifying results. In 2020, we noted 188 failures during the inspection routes. After the improvement, the vibration occurrences were mapped, being treated as alerts and sending automated reports for decision making. In 2021, there were a number of incidents detected immediately when they occurred. This led to a total avoided cost of more than 4 million reais, or about $800,000. In addition to all of this, the monitoring contributes directly to the reduction of noise exposure for the plant predictive team, who was now able to handle the vibration collection activity remotely. The gains in safety were many, decreasing the severity of activity in the risk matrix, going from catastrophic to light. Thinking of how to optimize the technician's performance in accordance with Vale's standardization processes, the technicians were trained to collect and use the new predictive maintenance and automated collection system. On November 30th, 2021, the online monitoring work on conveyor belts was disseminated via Gilberto Campos, interim manager, to the CEO of Base Metals, Mark Travers, who held the position at the time, and to Base Metals Maintenance Story magazine. This work represented Sossego in the Base Metals Maintenance Story 2021.